Hi, my name is Adrian. I live in Brazil. My EDX account is NightSoT12 and my GitHub is Joshua. Leaky Vessels is my project name and also vulnerability. This vulnerability is related to arbitrary code execution and authorization flaw. I choose this topic mainly because it's open source software and the software is runC. runC, according to its repository, is a command line interface tool that can be used to spawn and run containers, and it's according to the OCI specification. OCI means Open Container Initiative. But what is containers? Containers is an isolated application with its dependencies. Dependencies can be programming language runtimes, libraries, and other software. And containers is vastly used by developers and common users. Common users use containers to run applications, and developers use containers to develop other applications or the application. Those containers and those containerized applications are shipped by images. An image have the application libraries and runtimes pre-installed on it, ready to use. If a developer uses Docker to run an image, it's have an entire environment to develop inside of it, on it. And I use Flatpak to run a container image, a Flatpak app to draw the window on screen and get things done. And containers does not works alone. It needs a container runtime to manage the container needs to the host system and the host system needs to the container, like permissions or file descriptors. And the container runtimes need to ensure that the container does not access the host system directly, and the host system does not access the container directly because it's a security flaw if it can does. And it's what runC is. runC is as a container runtime, and it's vastly used by other software too. It's a dependency for Docker and Kubernetes, by example, because it uses runC to manage at low level the containers, and at the high level it's manage the user interface to become more friendly to developers use containers. So what's the problem? The problem is leaky vessels. Leaky vessels, formerly CVE 20, 24, 21, 6, 26. It's a file descriptor leak found in runC software. This file descriptor can provide to the container application a chance to access the host file system and or even complete access to the file system. But how it does? Well, a file descriptor is how a Unix-like operating system like Linux and manage the process or a running software permissions to the system computer. So those files for every process, it's have its own list of file descriptors, and those file descriptors given the permissions to the process measure things to get things done, like change a file or draw a window on screen. And run C, and the problem lays when run C initialize the containers and manage those file descriptors to the containers. What it does is when the run C initializes, it leaks file descriptors with privileges, and those containers that run C is managing can access those file descriptors by changing its working directory to the file descriptor path, and to the file descriptor path it can access to the host file system. But it alone is not exploit against run C, but a malicious image can take advantage of it. And what a malicious image can do, and a malicious image, it can, when run C is running and initializing a container, the run C, the container image can take the application, make a symbolic link through the file descriptor of the container runtime, and achieve the file descriptor path at the host system. And with it, it can access the host system, just access. The other way, if when the user or developer is importing a working directory for the container, that is when the user type the complete path to the container, change its work directory, the container application realize that the user using this command and trick the user by switching the path to the file descriptor path. And this file descriptor path, when the container completely initializes the application, it's changed the work directory to the host system instead of changed to the indicated path by the user, and it have the file system too. But it can be even worse. Using this method of looking at the file descriptor, instead of make a link to the file descriptor, it can make something even worse. It could change the host binary, like the bash. Bash is a common shell in every Linux distribution. So when a terminal application is open, the bash is executed. And if an application of that image changes the bash application, by example, and switches for a script that gives privileges to the container application to run freely, when the user runs that application, what it will do is give the privilege to the container application, and the application gets the full control of the host system because the user give the access by running this script. So how can we prevent it? Unfortunately, there's not software mitigation countermeasures, and the most common way to solve this is the update the run C package. And if you use a software that runs C, it's depend on run C, rely on it, update it too. And at last, check with your container images is changing the work directory in a common way, because it can possibly trying to get access to the host file system. Those are the references, my references, and the first is the article I found out the problem. And that's all, and thank you to reaching the end. Bye.